Welcome to your channel that teaches you corporate English every day.
Imagine you just received a request from a real client. They want you to build a system from scratch, not a tutorial exercise, not a classroom example, but something that will actually be used. Before writing a single line of code, your first responsibility is to translate that request into structure. The mistake most developers make is opening an editor too early. Real software is not born inside the code editor. Real software is born in the mental model of how the system will live, grow, and be maintained. When you start a project properly, you do not ask, "What do I code first?" You ask, "What are the parts of this system and how will they talk to each other?" A project becomes stable when its structure is intentional. If you try to design structure later, after code already exists, you pay a much higher price. The first layer of thinking is about boundaries. A real project is never one thing. It is many responsibilities inside one system. You must separate those responsibilities before they mix into a tangle. For example, business rules should not live in the same place as raw database access. Handling an HTTP request should not be mixed with authentication logic. The separation is not for beauty. It is for survival. When separation exists, things can evolve independently. When everything is glued together, any change becomes dangerous. So how do you decide the structure? You start by asking, what are the core responsibilities of this system? In almost every backend project, you will have at least these categories of responsibility. Entry points where the system receives external requests, business logic rules, and decisions that define how things work, data access, reading, and writing information. Cross-cutting concerns things that apply everywhere, like authentication or logging. Utility supports small helpers not tied to one domain. Well-structured project. Let's make sure that each of those lives in its own place, instead of blending together, before creating folders or naming anything. You should simulate the flow in your head. If a user asks for X, where does that request land first? Where does the decision happen? Where is the data fetched? Where does it return from? Where is the rule enforced if something is not allowed? If you cannot answer that in plain English yet, you are not ready to create the code layout. The second layer of design is direction of dependency. Good architectures flow in one direction. High-level rules do not depend on low-level details. For example, the business logic should not depend on the database implementation. The database implementation should depend on the business logic needs. If you flip that, the system becomes fragile because any database change breaks everything above. The third layer is future-proofing. You do not design structure for the code you write today. You design for the code you will need to write 6 months from now. Will this feature grow? Will other features appear next to it? Will another developer read this file and understand it without you sitting next to them? Real architecture is not about satisfying your present comfort. It is about protecting your future from chaos. Most beginners think architectural thinking is advanced. In reality, it is the opposite. It is the foundation you need before writing even the simplest feature. Without structure, even small features corrupt the project over time. Once you have the responsibilities, the data flow, and the dependency direction clear, only then you move to folder organization. The folder tree is not the architecture. It is only the physical reflection of the architecture you already designed in your head. People who start by creating folders without mental clarity create meaningless folders. When you structure a real-world backend, you are not trying to make it look clean. You are making it maintainable, explainable, and expandable. A clean-looking project that cannot grow is worse than a messy one that has solid principles behind it. Before writing your first file, you should be able to say the sentence clearly. If someone asks the system for X, the request enters here, the logic runs here. The data is handled here, and the response is produced here. If you cannot explain that verbally, you are not ready to structure or code. Asterisk, once that mental map is solid, you begin translating it into a structure with physical separation. The goal is not to create folders for the sake of folders, but to reflect the logical separation of responsibilities in a visible and predictable way. A developer who opens the project should immediately understand where to place a new rule. where to update a feature, and where not to touch. In a real system, one of the most important decisions you make early is where the rules live. Business rules are the truth of the system. They define what is allowed, what is denied, what happens under specific conditions. These rules must not be scattered across random files. When a rule changes, you should know exactly where to go. And that file should not contain networking code, database calls, or presentation details mixed into it. Another important part of structure is defining an entry layer. The entry layer is simply the part of the system that receives external interaction. That could be a web request, a scheduled job, or a message from another system. That layer should not contain the business rules. It should only take the incoming request and pass it down to the correct logic unit. Think of the entry layer as the receptionist. It's not the decision maker. Then you design where the data lives, not physically in a database, but logically in your architecture. The system needs a dedicated area that is responsible for interacting with data storage. This prevents you from sprinkling data calls everywhere. If data interaction is centralized, changes in database technology or structure do not break the rest of the system. You also must think about repeated behavior across the project, authentication, validation, logging, error handling, and so on. These are not features. They are rules that support every feature. If you mix them randomly into features, you create repetition and inconsistency. A structured system isolates these cross-cutting concerns. They can be reused consistently without rewriting them many times. At this stage, you have structure without code. This is the right order. Structure must exist before syntax. Code is the implementation. The architecture is the intention. Once you begin coding, if you follow the boundaries you defined rather than inventing new logic on the fly, if you need to implement a new feature, you don't ask, where do I put this? The structure already answers that for you. That is the signal that you designed correctly. A common failure in real projects is allowing small exceptions. For example, a developer thinks, I will just do this quick shortcut here, or I will handle this rule directly where I need it because it's faster. Those exceptions are never temporary. They become permanent debt that slowly corrupts the architecture. A project rots not because of one big mistake, but because of dozens of micro-compromises. A structured project feels heavy and slow only at the beginning, but becomes faster over time. An unstructured project feels fast at the beginning and becomes painful and slow later. That is the price curve you must understand as a professional. If you are building something that will live, structure is not optional. Before finishing part 2 of this explanation, I want you to notice something important. Everything we've discussed so far has nothing to do with Node, Python, Java, or any specific tool. Good structure is language agnostic. You don't structure because of Node. You structure because systems need order to survive. In closing this segment, a real project is not a pile of code. It is a controlled system of responsibilities. Architecture is the act of deciding those responsibilities and organizing them, so the system can grow without breaking. If that is clear, then you are mentally prepared to move from abstract structure into the practical act of planning the actual layers and flows of a back-end project.